Here we have another example from chapter 10.1. This one is a word problem. I've sort of condensed it down to what we need here. It has to do with the speed of sound in air is given by this function here, s of t. And s is the speed of sound in feet per second. And T is the temperature of the surrounding air in degrees Celsius. So T is the input to this function. S is the output. We call this S of T, and we're given this expression, and we're asked to find two outputs for two individual inputs. Trying to get rid of that glare. All right, so first we want to find the speed of sound in air when the temperature is 0 degrees Celsius. Now, if you know anything about Celsius and Fahrenheit, you know 0 degrees Celsius is freezing temperature. 0 degrees is 32 degrees Fahrenheit. So all we do here is plug in 0 for T and find out what the function is. So we say S of 0 is 1087 times the square root of 0 plus 273 over 16.52. All right, so we get our handy dandy calculator, we put our glasses on, and we calculate that. 1087 times the square root of 273. I'll give you the numerator there so you can kind of check. Comes out to 17,960.18755. That's the numerator. We divide that by the denominator of 16.52, and we get 1087.2, and it was feet per second. So that's kind of interesting because 1087. So that must mean the square root of 73 is very close to 16.52. And if we actually look at that, square root of 273 is 16.52 and a couple of decimals. But that's why this number is so close to this one. So that's our answer for the speed of sound in air that is 0 degrees Celsius. And let's see exactly what it asked us to round to there. It was round to the nearest foot per second. So the nearest foot per second would be 1087 feet per second. So that's going to be your answer to 31A. All right, and 31B, we're just evaluating that function for 25 degrees Celsius, which is much warmer, right? 25 degrees Celsius is probably 80, 90 degrees, something like that. So we plug that value in to the function, 1087 square root of 25 plus 273, and we divide that by 16.52. So once again, now we're going to get 1087 times the square root of 273 plus 25, which is 298. And that number comes out to be 18,764 and change. I will just say 53. Divide that by 16.52. And to the nearest foot per second, we get 1,136 feet per second. So quite a change there, right? Quite a bit of difference. Well, I guess not a whole lot, but 50 feet per second between freezing and very warm temperature of 25. 25 degrees, let's see. Celsius is 9/5 C plus 32. So 9/5 times 25 plus 32, 77 degrees. I was exaggerating a little bit, but 25 degrees Celsius is 77 degrees Fahrenheit. And speed of sound in 77 degrees Fahrenheit or 25 degrees Celsius is around 1136 feet per second. So there we go. Section 10.1.